Hey, hello everyone. We'll go ahead and take a look at section 21G, which is called tangents and normals. Now let's go ahead and just get an idea of what a tangent line is and what a normal line is by first taking a look at the graph. So let's say, for example, we have a particular function, and let's go ahead and call it f of x is equal to x squared plus 1. So I've gone ahead and graphed that function here. Now, if I was to go ahead and talk about the tangent line at x is equal to 1, if I was to try to find that equation, well, basically I need two things. I need to know what the coordinate is that the line is actually passing through, and the second thing is I need to know what the slope is. Once I know those two pieces of information, I can always calculate the equation of the tangent line through that point and tangent to the curve. So, if I was to go ahead and take a look at the tangent line at x is equal to 1 on this function, well, I need to go ahead and first find out the coordinate. Well, that's very simple enough. We just go ahead and substitute 1 in for x, and I come up with 2, and I know then that the coordinate that the tangent line must go through is 1, 2. So we're talking about this point right here. That's the point 1, 2. Right there. Okay, now we need to go ahead and find the slope. Now, of course, we've been working with the derivative, and so we know that the derivative is going to be the instantaneous rate of change, or the slope of the tangency line at the point 1, 2. So if we go ahead and show that the slope of the tangency line is indeed the derivative evaluated at the value of x is equal to 1, then I can first go ahead and determine what the derivative is, and we know how to do that. So the derivative of f of x is going to be just 2x. And if I go ahead then and substitute the value of x to be 1, I come up with the value of 2. So notice that the slope of the tangent, which is the same thing as the derivative at 1, that slope is 2. So what I can do now is what I can do is, being that I have the coordinate and the slope, I can always find the equation of the line. So I use y is equal to mx plus b. I know that the slope is 2. And I know that it goes through 1, 2. So I can then go ahead and substitute the 2 in for the y, the x for the 1. And I can solve for b, which in this case will be 0. Therefore, what I know is that this line here is actually going to be the equation of the tangent line at x is equal to 1 for this particular function. So let's draw this. So we know that the y-intercept is 0, and we know that the slope is 2, so it goes up 2 over 2, up 2 over 2. So if I was to draw this, this is what this line would look like. And of course it would continue on. Okay, and there you go. That's how we can determine the equation of the tangent line for any particular curve, given that we can calculate the derivative and know where the point is. So now we need to go ahead and also talk about the normal line. Now the normal line is going to go through the same coordinate, 1, 2, because we're evaluating the normal line at x is equal to 1 as well. Now the initial statement, or the relationship between the tangency slope, the slope of the tangent line and the slope of the normal line, is that the slope of the normal line multiplied by the slope of the tangent line is going to be equal to -1. And that's a result that we had from before. So if we go ahead and just solve for the slope of the normal line, that's going to be equal to -1 over the slope of the tangent, or the negative reciprocal of the tangency slope. So given that we know this, we can just substitute that value in there for 2. So we know that the slope of the normal is going to be -1/2. It goes through that point. So we can go through the same process to come out with this particular equation for our normal line. Now, if we go ahead and graph that, that is going to have a y-intercept of 2.5. So here's 1, 2, 2.5. And it is going to go down 1 over 2. So down 1 over 1, 2. Down 1 over 1, 2. And so this is what that line will look like. Okay? And so notice the relationship again between the normal line and the tangent line is that they are perpendicular to each other. So to wrap things up again, we know, being that we have the tools to be able to find the instantaneous rate of change of the function at any particular point using the derivative, we can find the equation for the tangent line, and once we know the slope, the instantaneous rate of change at a particular point, we can also go ahead and calculate the equation of the normal line as well. Okay, so let's see how everybody does, and good luck. See you next time. Bye-bye.